Okie dokie. Today we're going to be looking at something called the Coriolis effect that causes hurricanes to rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. So let's take a look at the Coriolis effect that affects hurricanes and tornadoes in the northern hemisphere, the southern hemisphere. The first thing we're going to do is study the northern hemisphere. Notice I've labeled this north, and this will be the equator. And the Earth is going to be represented by this sheet of paper. We're going to be able to rotate it like this. Watch this. So the Earth, of course, spins counterclockwise when viewed from above. So it spins this way. And what we're going to do is look at an air particle that travels from the North Pole down to the equator down here. So notice that if we take the air particle and the Earth does not spin, the air particle will just go straight down like this. And somebody in space looking at the air particle would say, "Yep, it's going straight down." And somebody on the Earth would also say, "Yep, it's going straight down from the North Pole down to the equator." But that's only if the Earth was not spinning. Let's see what happens when the Earth spins. When the Earth spins, what we're going to do is we're going to use this blue railing here doesn't move. So what we're going to do is we're going to have the blue marker right here. And it's going to the ink will represent an air molecule, and what I'm going to do is slide the air molecule down to the equator. But at the same time that the air molecule slides from the North Pole to the equator, I'm going to rotate the Earth the way it normally does. So let's see what happens to the air molecule. It starts in the North Pole and tries to slide down to the equator. Here we go. And we're going to put a little arrow on there indicating the direction of flow. So you remember that the air molecule tried to flow this way. And if we notice that when the Earth was spinning like this, when the Earth was spinning, the air molecule still was going in a straight line from the North Pole to the equator from a man in space. You know, if a man was up in space, he'd say, "Yep, that air molecule is going straight." Do you see how it's going straight along the blue pipe? But a man on the Earth would not say that. You know, if the air molecule left Chicago and the Earth was rotating, it would end up in San Diego over here because this might be Chicago. But if the air molecule rotates right, it'll end up in on the West Coast or something. So what we see is that when air molecules try to move on the Earth, along the Earth's surface, from the North Pole to the equator, the air molecules always rotate towards the right. You see that? They turn towards the right. So if this was a cow running, the cow always runs towards the right when the air molecule is going from the North Pole and trying to get down to the equator as the Earth rotates. Let's see what happens if an air molecule tries to go from the equator to the North Pole. Will it turn left? Will it turn right? Which way will it turn? And we're going to do that with a black marker so we can tell the difference. And let's see what happens when the air molecule, still in the northern hemisphere, but now the air molecule is going to try to go north. Let's see what happens here. And so here he goes. And there's the air molecule. And I'm going to draw an arrow so you realize that was the flow of the air molecule. So again, I still went along the beam. So a man in space would say, "Yep, that air molecule went in a straight line." Do you see that? He went in a straight line. But a man on the Earth would not say that. He'd say, "Hey, this air molecule started in Texas. By the time it was done, it went over to the East Coast and landed in New York, you know. So a man on the Earth would not say that the air molecule went in a straight line, whereas the man in space would say, yep, that air molecule is going along the blue rail in a straight line, so the man in space sees something different than the man on Earth. And of course, the man on Earth is what's more important, or woman, or whatever you want to think, because the person on the Earth is going to feel that force, that air molecule on his face hitting a certain way or another way. Now let's notice the air molecule. What it did again, the air molecule, notice, did curve to the right again. That's interesting. So whether an air molecule comes from the North Pole down, it curves to the right. And when an air molecule goes up to the North Pole from the equator, it also curves right when we're in the Northern Hemisphere. We're going to try the Southern Hemisphere in a second, although as we can imagine, everything would be just flipped. So we've done an air molecule going from north to the equator. It spins, it moves to the right, to its right, according to a man on the Earth. We've done an air molecule that goes from the equator up to the North Pole, and it curves towards the right. How about an air molecule that's just going, let's say, west? We're going to try to do that. It's going to be a little bit thing. So I'm going to try to, I don't have a railing for this, but I'm going to try to draw a straight air molecule this way, and that's straight. But when the Earth rotates, what's going to happen to the man? You know, the man in space will say, "Yep, the air molecule is going straight from east to west." But what will the man on the Earth say it does? So let's try to do that. Let's try. We'll start him right here, and we'll start drawing him. And here we are drawing him and rotating at the same time. And lo and behold, look at that! Even though the air molecule was trying to go straight, it was going straight according to the man in space. As the Earth rotated, it also turned right. That's interesting. So it looks like no matter what happens, the air molecule will always curve to the right in the northern hemisphere. Let's try another. Air molecule. Let's try an air molecule right here. Yeah, we'll do them over here. We'll do an air molecule this time going towards the east. And let's see what he does. We're going to go straight across try to go from here to here, but he's got to live on the piece of paper, so let's make him live on the piece of paper. There he is living. And he's going to try to draw. And sure enough, the air molecule again turns towards the right. So whether where the wind is going towards the east, it curves right. If it goes towards the west, it curves right. If it goes from north to the equator, it turns right. And if it goes from the equator up to north, it turns right. No matter what, an air molecule always turns right. So let's see. Notice if we were to pin this thing on the bottom here, we could then, since the Earth, when you look at the South Pole, the Earth rotates this way on the South Pole. It rotates like this. If you look at the bottom, if you float above the South Pole down here, if this was the South Pole and you look at it and you look at the Earth, it'll twist around like this if you watch it from space. So when we put the pin up here, we're simulating looking at a northern hemisphere. When we put the pin in the bottom, we're simulating the southern hemisphere. And we'll do a bunch of southern stuff right here. I'm going to mark it off so it doesn't get confusing. So this is all the southern experiments. Let's see what happens in the south here. Well, in the south, if we notice, if we start an air molecule here at the this is southern stuff, but this is the South Pole and this is the equator if you're in the South Pole. So that's the equator. Getting a little bit messy. But here's the South Pole. And we could go from the, let's go from the equator. Oops. Oh, we lost our tack there. So I'm going to put this here. Let's go from the equator to the South Pole. Let's see what an air molecule will do. I'm going to start it right here. Nope. I want to start it actually right here. We'll start right here. Okay. Let's let the Earth spin. Let's let the Earth spin and watch what the air molecule does as it tries to move from the equator to the South Pole. Here we go.